Hello everybody. Today I'm going to look at chapter 7.2.1 and it starts with three experiments, talking about the three experiments that Faraday did to prove or to find out this thing. So the first experiment he did was, have a plate with a magnetic field pointing inside our paper, in our case, that's why I put in, and then also the correct notation, and then a wire with a resistor on top of it. So what did he do? Well, the first thing that he did was take the wire and move it away from the magnetic field. So I started, for example, from this position right here, and I started moving it away, so toward the right. What did you find? What did you find out? Well, when we move our circuit to the right, we have a current that flows this way, or counterclockwise. Then what it did was, instead of moving the wire, he decided to move the plate. Well, he moved the plate in the opposite direction. Oops. Okay, for some reason it doesn't want to take the color. Okay, I'm just gonna have this. Okay, so it took the thing and he moved it towards the left. So away from the loop. Okay, we can say you started like this and then it moved away from it. Well, what happens when we move away from it? Another current is generated, always counterclockwise. Sorry, all clockwise. My bad. Both of them were clockwise currents. And then one last thing that he did was, instead of moving either one, he changed the magnitude of the magnetic field with time. So the magnetic field was changing over a certain amount of time, over a certain time. So what did he notice? Well, again, the current was clockwise. Well, of course, we can start to see something very interesting. In the first one, for example, we can see that something is generated when we change the area that these two have in common. So, for example, if we move this to the right, as you can see, the area is now restricted to this. Then if you move more, it changes to something even less, this. Okay, so same thing happens with the second one. The area changes, the area in common. And then with this third one, what changes? Well, B changes. So we have to find something that is in common for all three of these. Well, something that is in common is, well, let me write it down. We can say it's B times dA is equals to the flux. Well, when this changes over time, because of course we see that it takes some time to change any of this, or when we do this, d over dt, you know what, let me do this over here. D over dt of this part over here, or d over dt our flux, then we have negative EMF. Now we use negative because the EMF is gonna go clockwise. It's gonna go in the direction of the change, is opposite direction of the change of our field, our flux, sorry. For example, in the first one, we can see that our flux decreases because of course we're decreasing the area. Therefore, it's gonna go downward in the same direction as B in order to counteract the change. So one thing important to understand here is that EMF is just trying to put everything back to how it was an instant before this change was made. And one thing that we can realize that the EMF is the change of electric field over a closed loop, and we said of course is equals to a negative, the derivative of our flux over time. So we can just say that these two are the same. We can start ignoring the EMF, and this is just Faraday's law in integral form. We can rewrite it in the other way, So the curl of V is equals to the negative partial derivative of B over T. Over T. By using Stokes' theorem, of course. So whenever we have a change in the flux, whether it's because we're changing the area or we're changing the magnetic field, we're changing the magnetic field, or whenever we're changing the area, so as you can see in this formula right here, magnetic field or the area, we're going to have a change in the flux. And a change in the flux over time induces a change in current or EMF. So here will be equals to, this is proper notation, negative d flux over dt. That is the answer to our whole first section of this chapter, to be honest, and most of the chapters anyway. So now I'm gonna stop here and next one show you the examples that are shown in the book.